All right, so this is, I know it reads question 1, but it'll be the second of the 2 questions that we do, or that I do for you as demonstration. Since they're uniform distributions, I'm already drawing my axes, and we'll see what this problem has to say. Births are approximately uniformly distributed between 52 weeks of the year. So it goes from 1 to 52. So I'm going to mark this left as 1, and this over here is 52. This is my B, this is my A, this is at 1, this is at 52. And then this is the function f of some constant, my uniform distribution. So that's f of x equals, I don't know yet, it's some constant. You can also think of it as it's at the height or at the y value, or intersects the y-axis at some number. And we have to calculate that, if you recall from the previous problems. And I do all of this work prior to diving into the problem. We could do the first 2 without doing this work, but anyway. I need to find the height of this rectangle, so this dimension here. And I can calculate this dimension here, because that's b minus a, which is 52, minus 1, which is 51. So the distance between the 2 orange vertical lines is 51. And that's the length of my long, skinny rectangle that I have here. And recall that the area of this rectangle, since it represents a probability, the area is equal to 100%, or 1. And so if the area is equal to 1, and we calculate the area of a rectangle using base times height, or length times width if you prefer, then 1 equals the base times the height. If I substitute base as 51 and the height as h, since I don't know it, I can divide both sides by 51, and I can determine that the height of this function is 1 over 51, or the y value that this function intersects at the y-axis is y equals 1 over 51. And so those are the dimensions of my rectangle and the information that I need to continue on with this problem. Now, to calculate the mean is just the average of A and B, or the value that's halfway between A and B, because that would be the middle number. That would be the mean for a rectangle, but that's not necessarily easily understood. So there is a formula if you prefer. The mean of a uniform distribution is A plus B divided by 2. And so that's 52 plus 51 divided by 2, which is 53 divided by 2, which is 26 and a half. Or I so believe. Let me do that math. 53 divided by, 53 divided by 2, 26 and a half. And remember, if you've forgotten that, you can find that in the slide deck for this section. The mean for a uniform distribution is that. The formula for the probability distribution function is that. But we've been doing this. We just do it by calculating the height of the area of a triangle. But once you do this enough, maybe you'll recognize that. That's the arithmetic that we do. Okay. And then this will be the standard deviation, which is the next part of this question. So this is 26.5. They've seriously... Oh, I misread this. It goes from 1 to 53. And therefore it's 27. So let's go back and correct that. This is 53. Sorry about that. And that means this is 53. And this is 52. I'm sorry, 54. This is 53. This is 27 then. That's not very good. And this is 1 over 52. Because I'm a doofus and didn't read the question closely. I saw this, it just started going, but 1 through 53. Okay. Now that I have my A and more specifically my B correct, we can calculate the standard deviation, which is the square root of B minus A squared divided by 12. And so B is 53. I wrote it again, 53 minus 1A, all that squared divided by 12, and then take the square root of the whole thing. So that's 52 squared over 12 square root. And so I get 52 squared divided by 12. And then I can hit enter and use the square root symbol and enter the answer and get 15.011107. But if I round to 4 decimal places, as the instructions indicate, this would be 15.0111. Okay? Remember, when you're watching videos, you should be taking notes and all that kind of stuff, and hitting pause. And really, when I start saying, start talking about this next section, you should try to do it on your own instead of just watching me do it, because you're going to learn more if you actually do the thing. And I would say do it, and then see if your work matched mine, or at least your method is repeatable and you get the same answer that I get. All right? So here, the probability that a person will be born at the exact moment that week 29 begins is probability of x equals 29. Hopefully from our conversations, we now understand that that probability is 0. And if you don't recall, or you've been absent, you can go look at the properties of a continuous probability distribution, which the uniform distribution is one example of. But these are the properties, and notice this fifth bullet, P of x equals some constant, is equal to 0. And we talked about it in class because the line can't have an area, and all of these probabilities are areas of underneath this curve down to the x-axis. So that area is equal to 1, and a line, a vertical line or segment in this rectangle, cannot have an area because it's singularly dimensional. So this is 0. The probability that a person is born between weeks 11 and 34. So between weeks 11, oh my goodness. Between weeks 11, let's use blue, 11, where's 11 going to be? Maybe here-ish. And what? 34? Maybe here-ish. So we're talking about this area. So 11 to 34. So again, we are just calculating the area of a rectangle. So how do I calculate the area of that rectangle? Well, you would figure out what this distance is. So that's 34 minus 11. And you would multiply that length times this dimension, which is the height, 1 over 52. And so we get the area of that rectangle to be 34 minus 11 is 23, times 1 over 52, which is 23 over 52, which is a bit less than a half, maybe 44%, maybe 46, I don't know. So what did I say, 23 over 52? Not 20, yeah, 23 over 52? Yeah, 44%. So 44.231% or 0.4423. Okay? So at least this video won't be as long and painful as the previous one, because you should have watched that one first, maybe. If you watch this one first, then maybe you want to go for the other one afterwards, and that one will be longer but slower if this one was a little tricky for you to grab a hold of mentally. Okay, so the next question is the probability that a person will be born after week 11. Notice that after week 11, piece of poop. It's going to strangely do that thing again, isn't it? No, it didn't. Okay. So week 11, happens to be the same 11, and that's just arbitrary. They're generating a random number there. So they're saying greater than 11. But remember, all of them are happening before week 53 occurs, so it's between 11 and 53. So we're really calculating the area of this large rectangle to the right of 11, where my blue arrow is situated. So the probability of x being greater than 11 is the area of the rectangle with this dimension. So that's 53 minus 11 times the height, which is 1 over 52. Oh my goodness, 1 over 52. I just noticed this and it messed me up. So that's going to be 53 minus 11 is 42 times 1 over 52, which is 42 over 52. And so that's going to be like 81% maybe. 42 over 52. So 80.769, which rounds to 80.77, so 0.8077. Okay. Now this is the most difficult, I believe, difficult portion of this problem, the most difficult individual question within the set of questions for this scenario, and it's this conditional probability thing. Okay. Now in the other video that I just posted before this one, so you can hit this YouTube channel if you wish, I try to explain this, and I'll try to explain it again now so that it's not segregated. You don't have to go look at the other one, but there's I explained it there. So this is saying, what's the probability of x being greater than 10 given that x is less than 34? Okay, that is not the same as between 10 and 34. That's not the same as that. Okay, it's not the same as between 10 and 34. It's saying what's the probability of x is greater than 10 when we already know that it's less than 34. So it's almost as if this part of my rectangle doesn't exist. So we really are trying to find what is the percentage of this rectangle compared to this blue bordered rectangle. What percentage of that white rectangle that I have scribbled in over here compared, or what is it, a percentage of the blue rectangle? So what I'm going to do is I'm going to find the area of the white part, so the area of white, which is the probability of x greater than 10 and less than 34. Oops. And then I'm going to divide that by the area of the blue, which is the probability of x between 34 and 1. Okay? And then I'm going to divide them. This is going to be equal to the probability of, it's going to be the probability of that white part, which is A white, divided by area blue. Okay, so we're going to do this one first, and that's going to be this 10 to 34, so that area of white is equal to 34 minus 10 times 1 over 52, which is 24 over 52. I'm just going to leave the number like that. And then the blue is the whole thing, so that's 34 minus 1 times 1 over 52, which is 33 over 52. And so when I calculate the probability of x greater than 10, given that x must be less than 34, which again means that we already know that this part is gone. It's not considered. Okay? It's not part of our answer. We're trying to understand what is the fraction of the white out of the blue. And so that's going to be this number, 24 over 52, divided by this number, 33 over 52. But remember, dividing fractions don't ask why flip the second to multiply, or keep, switch, flip. Or I didn't go into it in the other video, but I'm going to tell you, I don't think of it that way, and I wish we could. I wish the math world would get away from it, just absolutely get away from it, and talk about it this way. Just understand that when I divide something by 2, that's the same as multiplying times its reciprocal. So when I divide something by 2, it's the same as multiplying times 1/2. Or you can say when I multiply something times 1/2, that's the same as dividing by its reciprocal. So what's the reciprocal of 1/2? 2. So I can divide by 2. They're the same. You already know this. If I divide something into half, 2 halves, 1/2 is half of the stuff, whatever it is. If I divide it by 2, it's half the stuff. Okay? If I divide it into 3 equal pieces, one of those pieces is 1/3. If I multiply times 1/3, I get 1/3. So 9 divided by 1/3 is 3. That's 1/3 of 9, right? So instead of doing that, keep switching from blah, blah, blah. If it works for you, keep doing it. Don't change anything. But I'm trying to expand the way you think about this so that this stuff maybe is easier for you. I don't know. Instead of dividing by this fraction here, I'm going to multiply by its reciprocal. So what that means is I'm going to take 24 over 52, but instead of dividing by some fraction 33 over 52, I'm going to multiply by its reciprocal, 52 over 33. These two equal 1 because 52 divided by 52 is 1, and I get 24 over 33. And that's going to be my answer, 24 divided by 33. Now, the other problem with the 82% thing, that was harder to talk about because the scenario was more difficult. I think these are easier. They're more direct. The other one, you have to think sort of backwards about it, but I tried to explain it, and I think that's the most difficult of the scenarios, but I suppose we'll find out. So 0.7272 repeating. Okay? Rounded to be 7273. Okay, so I'm going to back all this out of here because there's a whole bunch of scribbling. And then oh yeah, it is. Okay, so as I do this, the next part is find the 82nd percentile. So remember, 82nd percentile is 82 and below. So I'm trying to find the number that represents the 82nd percentile. So I'm going to sketch in the area of the 82nd percentile. That's not what I wanted. How do I close this like that? There we go. And I'm doing it this way, even though it's slower, because it's going to be harder to erase all that squiggly stuff overlapping on the other lines and whatnot. So I'm going to draw a line that represents the location of the 82nd percentile, and then I'm going to shade in the 82nd area. And then we're going to calculate the area. We're going to do a backwards area problem where instead of calculating the area, we're going to know the area because it's 0.82 and calculate the, yeah, it's doing this weird, keep the green scribbles there. So I'm really going way, way back. I'm going to stop there. Somehow the software doesn't understand and do everything's explicitly in order. It's just weird. Let's change the green, put that 52 there. Okay. So let's say that this represents 82. Let's do it on a blue. So this is 82% or 0.82. Okay? Then this number, I'm going to put a little C there. We don't know the number that goes with it, but that's what we're going to find out. So if I'm going to calculate the area of this rectangle, which I already know is 82%, and then try to determine this C value, we would want to know the length of this distance because we already have the height, 1 over 52. So that's going to be C minus A, which is 1, and the height is 1 over 52. Okay? And so 0.82 is equal to C minus 1 times 1 over 52. If I multiply both sides by 52, this equals 1. I'm left with C minus 1, and this is 52 minus 0.82. 52 times 0.82, which is 42.64. And then I'm going to add 1. Yeah, add 1. and I'm going to get 43.64. So what we're talking about is 43.64. 82% of births happen before week 43.64, before week 43 and a half or 44, however you want to say it, of the year. Okay? So 82% of the births happen before week 44. But this answer will be 0.4364. Oh, no, I'm sorry. It'll be 43.64 because it's a number, not a percentage. Now they say find the minimum for the upper quartile. So the upper quartile happens at 75%. So we're going to do the exact same thing that we did. It's just a different way to word the problem. We're going to look for value C. And really, you don't even have to move the rectangle. If it's not technically to scale, I can just imagine the same rectangle, or I can squish it or whatever. But I could also just do this and say, oh, now I'm trying to find this area, but the area of the rectangle is 0.75. So the area is equal to 0.75, and that's equal to base times height. So 0.75 is equal to the length of the base, which is C minus A, but A is 1. And the height is still 1 over 52. So hopefully you can see that this is the same problem we just did. It's just that this 75 is no longer at 0.82, it's 0.75. I'm going to multiply both sides by 52. On the right-hand side, I get C minus 1. On the left-hand side, I'm really now keeping, instead of keeping 82% of 52, I'm keeping 75% of 52. Oops. Oh, I can just back this in and put 0.75 there, and this is 39. And then when I add 1, I get C is equal to 40. So the answer to this part should be 40. Okay? So I hope that is helpful. Hope those two are helpful. Send me questions if you have them. Have a good weekend.